Hi everybody, in this video we are going to discuss about how to solve this factor index numbers problem, and we are going to use ternary operator and lambda function as well in Python to solve this problem. So first let us understand the problem. So the statement goes like this: a number n in a list at index I. We are going to follow human indexing, which means that the index will start from 1. Is said to be factor indexed number if I is factor of n. Given two lists L1 and L2, form a list L3. Okay, so you are going to form list L3 from elements of L1 and L2. And a glimpse of the procedure is also given. Initialize index to 0. Visit elements of L1 and L2 at index. If one of them is factor indexed, insert and increment index, go till the end of the list, right? If one of the element in either L1 or L2 is factor index, then you will add to L3 and you will proceed. Otherwise, if both of them are factor index, then you have to add the element of L1 first and then followed by the element of L2 in L3, right? If both of them are not factor index, we are just going to skip and go on, right? That's what is given. And after the construction of L3, you have to print the numbers which continues to be factor indexed in L3. Okay, so let us see the example and have a better understanding. For example, if the L1 contains these elements and L2 contains these elements, it's not necessary that equal number of elements should be there. Okay, so in the first list you have got 7 elements and in the second list you have got 4 elements. Let's follow the procedure. You start from the first index. I am checking 15. Whether 15 is divisible by 1? Yes, definitely. So 15 will be added into L3, and then you go to L2 and check the first element 45. It's also divisible, so 45 will be added. Now the second element 12 is divisible by 2, so add 12 to the resultant list. 34 is also divisible, so add 34 into the third list. And now 17 is not divisible by 3. 64 is also not divisible by 3. 32 is divisible by 4, so add to the resultant list. Now check 80 is also divisible by 4, so you have to add it to the L3. Now the elements in L2 are over, but still you have elements in L1. Then continue the procedure for L1 alone. So you are checking whether 42 is divisible by 5. This is at this is at position 7. 1, 2, 3, 4, 5, 6. So whether 42 is divisible by 6? Yes, it is divisible. So 42 will be added to the list L3. Now again with this L3 you are going to check if they are factor indexed. So consider 15 is divisible by 1, so it is factor indexed, so you have to print 15. And then 45, it is at index 2, it is not divisible by 2, so do not print it. Third position you have got 12, which is divisible by 3, so print it. 34 is not divisible by 4, so do not print it. 35 is not divisible by 5. 80 is not divisible by 6. And when you consider 42, it is divisible by 7, so you have to print it. This is the overall idea. And when you look at the input format, it is said that you have to read the number of elements in L1, let it be N1, and next N1 lines contain the elements of L1, right? And next line contains the number of elements in L2, that is N2, and next N2 lines contains the elements of L2, right? So this is the input format that we have to follow. Now let's write a algorithm. Let us do it in the code editor itself. So I have just mentioned the algorithm as first step is read the number of elements in L1. Then you are going to read the elements of L1 and build it. And then what you are going to do is find the number of elements in L2, read the elements of L2 and build it. After that you have to find the minimum length, because while we were doing, we observed that L1 contained 6 elements, L2 contained 4 elements. The minimum length is 4. So for up to 4 elements, we were checking first L1 and immediately L2. The order is important, right? So you have to find the minimum length. We create an empty list L3, and then for minimum length, you have to check if the elements of L1 and L2 are factor index, and you have to add to L3 if they are so. And after that, building the list L3, we have to check if the elements in L3 are still factor index. Whichever is factor index, we are going to print. This is the overall idea for solving the problem. And let us write lambda for finding out whether a number is factor of another number or not, right? So let me tell f5, let me call it as f5. I am going to tell lambda, two things will come, f and let me tell element and then factor, okay. So two things, ELE and f, and you have to return true if ELE is divisible by f, that's the idea, okay. So ELE is divisible by f means we are going to tell true, right. So what we are going to do is, we are going to check if ELE mod f, right. What will happen if ELE is divisible by f, the value returned will be 0, 0 is false. So I am just returning not of it, right, so that I will get true if ELE is divisible by f. So first let's check whether this lambda function is fine or not. So let's try this 32, 2. Actually I want f5 to return true because 32 is divisible by 2, right, that's what we expect. Let's run the code and check. Yeah, it's returning true. And if I give 32, 3, I want to return false because 32 is not divisible by 3, right. So you can see that it is printing false, okay. So the basic idea is you are going to check if the element is divisible by f, right. The value you are finding out, remainder you are finding out, when it will be 0 is, if it is divisible it will be 0, but we want to return true if it is divisible by f. So we are telling not, right, 0 is false, so you give just tell not for not before it to make it as our desired thing. And next is you are going to read the number of elements from the user. So let it be n1 and you are going to read it, and then you are going to build L1. So let's initialize L1 equal to null, and then you are going to read the elements one by one and then put it inside L1, right. So let me tell ELE equal to int of input, and I am going to tell L1 dot append of ELE, right. And then you are going to read the number of elements in L2, let it be n2, and let's read it from the user. Read the elements of L2 and you are going to build it. So before building it, let's have an empty list, and then you are going to tell for I in range 0, n2, right. You are going to get the element from the user and we are going to put it inside the list, right. So L2 dot append of ALE, right, and you are going to find the minimum length, okay. So let me call it as min length, and that is equal to, let's use the conditional operator, that like ternary operator, to find out. I will tell it is L1 if L1 is less than L2, and else otherwise we will tell L2, right. So in a single line we have told minimum length will be equal to L1 if L1 is less than L2, and it will be equal to L2 otherwise. That's what we mean here. And we are going to create a empty list here, and for minimum length we are going to write a procedure for I in range 0, min length, right. What should you do? You should check, right. First you should check if the element in L1, right. So if L1 of I is divisible by, you want to check whether it is divisible by the human indexing, right. Human indexing is one more than the system indexing, and be careful when we are writing the expression, we should be clear where to put parenthesis. Here we have to put parenthesis, otherwise what will happen is it will try to divide first time by 0 because the I value will be 0. We should be careful because I plus 1 should be evaluated before taking mod. Mod is having higher precedence than addition operator, so we have to put this braces, right, and you are checking if it is divisible by this. So you are telling equal to 0, then in that case you have to put it inside L3, right. So that's what you are doing here, and immediately I have to check if L2 of I whether the element at the index in L2 mod I plus 1, right, mod I plus 1 equal to 0. If it is divisible, then you are going to add it to the resultant list, right. So this will build the resultant list. So the next step is to check whether the elements in L3 are factor indexed, and we are going to print if so, right. So let me start for in. Oh yeah, one more thing before this. Actually now we have written only up to minimum length. So for rest of the things we have to write the code. So I am going to write like this for I in range. Okay. So I have to start from the minimum length, and I will be going up to n1, right, for the first list. You may have a doubt, if the minimum length is equal to n1, what will happen? If it is equal to n1, obviously nothing will be generated by range, so this loop will not execute at all. So it is not required for us to explicitly check if the minimum length is, whether it is the first list or the second list. It is not required. For our case, the example what we have taken, minimum length will be same as that of n2. So the second loop will not execute at all. That is the beauty of Python. The range function will not generate anything. So no worries at all. So I am going to now check for I in range from minimum length up to n1. I am going to check if L1 of I, right, if it is divisible by I plus 1, right. If it is divisible by I plus 1, in that case what I have to do? I have to add it to L3, right. You will append it and you will tell L1 of I, right. And similarly do the same thing for the second list. So for I in range, I have to start from the minimum length and I have to go up to n2, right, and I will be checking if L2 of I is divisible by I plus 1. Okay, if it is divisible by I plus 1, then I can add it to L3, append of L2 of I. Okay, right. So now only L3 is completely built, right. So in this case L3 is completely built, and now we have to check whether the elements are still factor indexed. So let us write a loop for I in range 0 comma len of L3, right. We have to go till the last element in L3. So len will be 1 more than the last index, so it is fine. And we have to check if L3 of I mod I plus 1, okay, is equal to 0. In Python we need not put the braces. If it is equal to 0, in that case you just print the element L3 of I. Okay, fine, right. Let's try to run this code and check and consider a case. Let me do that. I will consider this example. That is, the number of elements is 6, right. So let me give 6, and then I have given 15, 12, and then 17, 32, 26, and then 42, right, and 4 elements in the second list, 45, 34, 64 and 80, right. So yeah, I think I made some mistake. Let's go and check here. Min length, let me check min length. Oh sorry, here I have put L1, sorry, it is N1, that's a mistake. L1, no L1, L1 is a list, N1 is the number of elements. Actually based on the number of elements only we have to check it. So please make a note of this. Min length equal to N1 if N1 is less than N2, else L2, else N2. Yeah, let's run the code again. I have given the input, the same input, and you can observe that it is printing 15, 12, 42. That is our desired output, isn't it? So now let's copy the code into VPRPL and check it. Let me do that. So I'll choose the languages, close this. Okay, I will choose the languages Python and paste the code here and try running it. Yes, the code is passed. Thank you.